Algorithms improve decision making. But which algorithms and for what? If you want to learn more, follow me into the world of data science. My name is Anna Gründler. I'm a lecturer at Heinrich Heine University. And in this video series, I aim to demystify data science and put it in the context of management practice. I deeply believe that for every business person, it's important to understand the general idea of data science, even if you never intend to apply it yourself. After defining a use case and collecting the data, in this video, I'm going to talk about what data science models exist. Basically, it's about the following. How do we translate a use case into an algorithm? And I have to make a disclaimer. This video does not try to educate on algorithms in detail, but rather which analysis machine learning has to offer, and for what particular use cases they make sense. If you want a deep dive, there's plenty of dedicated lectures, such as Scikit out there. The basics. First of all, machine learning gives us the ability to learn things about the world from large amounts of data that we as human beings cannot study or appreciate. Machine learning is when we teach computers to learn patterns from looking at examples in data, such that they can recognize those patterns and apply them to new things they haven't seen before. To teach computers, you often need tens of thousands of examples. And from those examples, machines build a representation of the data, a model, from which it can make a prediction. So the process is you run the selected model based on a historical training data set, evaluate it based on the validation set. There are some general differences in how computers learn. First, there is supervised learning. The aim is to predict a known target. This required labeled data. A simple example. You show pictures of an apple, you add the label apple, and the models learn this. Then you add a new data with a picture of an apple without the label, and the model can predict this is an apple. This is often used for filtering spam emails, for example. Second, unsupervised learning. This aims to discover the structure, so there is no labeled data available. And maybe we can think about a fruit basket with different fruits as an input. But there are no labels this time. The model analyzes this fruit basket and finds patterns. So you don't tell what groups of fruits are there, it just finds it. This is maybe obvious for fruits, but for customer segments, it's more interesting. And third, there is reinforcement learning. Here the aim is to optimize actions in a way that it maximizes the cumulative reward. Think about the algorithm like a baby that tries out things and learns, for example, that an oven is hot because it is punished. This is also used for autonomous cars. So those are the generic concepts. But what models to choose? I'm not going to go into detail here, but I'd like to give you an overview of what algorithms are available and what types of business problems are solved. It is helpful to structure the types of models according to their outcomes. And there are four main classes: descriptive models, explanatory models, predictive models, and prescriptive models. You can find all three learning types from before in those classes. Descriptive models. They describe what happened. Examples of methods are classic descriptive statistics, but also cluster analyses that can help to find groups of similar customers. Explanatory models explain what happened. Examples of methods are regression analyses or decision trees. The simplest explanatory model is a linear regression. And when more explanatory variables are included, this is a multiple regression. Then there is predictive models. They predict what will happen in the future. And examples are also regressions by using the estimated betas, decision trees, random forest, time series analysis, or neural networks. In this category, the most exciting ones are the neural networks, as they mimic the functioning of a natural brain. The model takes an input, and returns a probability for each possible output. This can be used to understand language. And then there is prescriptive models. How can we make things happen? Examples include continuous linear programming or simulation. An exemplary question would be, what happens with the demand if we change the price for a certain product, often used in airline industry? All models need to be evaluated, and depending on the methodology, there are different ways to do so. Typical evaluation methods include accuracy, precision, recall, or the F1 score. And for you as a business person, it's vital to share what good looks like. So, for example, if we go back to that customer churn example, is it more important to classify most people right that are really going to leave and taking into account that there are a few false positives? Or should the algorithm get most customers right that are going to stay and optimize for this outcome? When you have the results at hand, you should do quality checks. Test the results with end users and plot the findings if possible. Challenges in this step in business practice are unsupervised training, such as deep learning is a black box. It only returns an outcome that is not easy to interpret compared to, for example, a regression. This leads, in reality, to the fact that most data science projects are regression analyses because businesses want to understand why things happen. Another challenge is that labeling takes time and is very labor-intensive. And lastly, the field is continuously reinventing. New approaches come up, then enable new analyses. The most fascinating one is transformer-based natural language processing that enables analyzing not only numbers, but also text. So watch out for what is yet to come.